In this demo, we can demonstrate the creation of actionable information out of raw data to reduce operational costs and increase efficiency of your pneumatic application. At the center of our IIoT approach sits our Smart Pneumatics Monitor, which is a gateway that collects the raw data that is already being communicated between the valve system and the PLC. It collects this raw data and enables us to analyze it and create the kind of value-add information that actually enables our customers to increase the efficiency and reduce the operational costs. This also means that our approach is independent from the machine control and can be added or modified over the lifetime of the machine without having to touch the PLC programming. Based on this, we can already show you some interesting use cases with this very simple setup. We have an air preparation unit with an airflow sensor and a pressure sensor. We have a valve system which is communicating with the PLC and is also collecting the inputs and outputs. And we have a rodless cylinder with shock absorbers and end position sensors, and of course our Smart Pneumatics Monitor. Our Smart Pneumatics Monitor now collects the raw data out of the valve system and, for example, can make assumptions about the expected lifetime of some of the used components. A very simple way to do that is by simply counting valve cycles and compare them to the expected lifetime of the valves. By timing that, we can calculate an expected rest lifetime of the valves. By this and by knowing how many valve cycles we have per day, for example, we can give an indication how long we are expecting those valves to last, which can give a very good indication about the expected life expectancy in the next maintenance cycle. Another lifetime indication we can give is for the shock absorbers at the cylinder. The shock absorber over the lifetime is getting more and more inefficient. That means it is a wear part which usually has to be changed in the maintenance cycle of the machine. This also usually means that it's exchanged too early because obviously it hasn't failed yet. What we can do now is we can measure the efficiency of the shock absorber during the lifetime of the machine by measuring the time it takes the shock absorber to actually stop the cylinder. The shorter this time gets, the less effective the shock absorber gets, and we monitor that for the whole time and give you an indication when this efficiency is actually decreasing. The second major use case is the advanced energy monitoring that we can do. Usually there's already a flow sensor within the pneumatic application which gives regular reporting about the energy consumption of the machine, maybe per week or per day or per month. We can now monitor also this in real time and correlate it to, for example, the machine cycle or the state of the pneumatic application. If we detect an anomaly in the consumption per working cycle, that usually means that there is a developing leakage, and we can give a notification that this is currently happening, like we can show in our application by creating an artificial leakage. Our approach to smart pneumatics is based on flexibility and modularity and on open communication protocols and open software. We have a global team of IIoT experts available in your region to support you in finding out how you can make your pneumatic application smarter. How do we now find out if this approach fits our customers' needs? One tool to do that is our Smart Pneumatics Analyzer. We basically took all the core components of our IIoT approach and put it into a suitcase so that we could bring it on-site to our customers and their machines and applications to gauge the potential for an IoT implementation and discuss the next steps.